Hello everyone. Thank you for joining me today in this conference. My name is Srinivas Reddy Mosali and I'm a senior consultant systems engineer at Visa. Today I'm going to discuss on an important topic on how to scale fintech infrastructure that never experiences the downtime. As you all know, fintech operates in a fast-paced, high-stakes environment where downtime is simply not an option. Even a few seconds of an unavailability can lead to a massive financial losses, regulatory scrutiny, and more importantly, a dent in customer trust on the organization. Okay, before we dive into the details, let's go over today's agenda. In this session, we will explore best practices, technologies, and strategies that can help us achieve zero downtime in fintech industries. We will start by discussing the foundations of high availability and architecture and how it ensures uninterrupted financial services. Then we will explore real-time scalability strategies to handle peak loads efficiently. We will then look at disaster recovery mechanisms and failover strategies to prevent downtime during any unexpected failures. We will then go through security compliance, which are critical for any fintech organization. So we will discuss how to maintain both without sacrificing on speed and availability. We will then look into the observability and incident response, which are crucial part of any proactive management of infrastructure. And we will also cover best practices in that particular area. Then we will explore container and cloud strategies in managing fintech workloads. And finally, we will wrap up this discussion by discussing on the maintenance strategies that minimizes the impact and how to achieve the overall zero downtime as a core fintech objective. Okay, so the high availability is a fundamental requirement for fintech companies. So it ensures that financial services remain operational even in the face of unexpected failures. So there are like two main approaches to achieving high availability. One is to have this active setup, and then the other one is an active passive architecture. So coming to an active setup, multiple systems like handles requests simultaneously, allowing seamless failover in case of an issue. And in an active passive setup, one system is kept on standby, which is more cost effective, but it may introduce a small delay during failover. So the multi-region deployments ensures like redundancy or preventing localized failures from affecting the service availability. We can also use load balancing at different layers of the infrastructure to ensure like the equal distribution of traffic is happening, and which will also prevent the overload on any particular single system. Additionally, we can also configure object storage replications, which prevents the data loss and ensures that users can always access their financial information even if there is an event of a failure. Moving on, so this slide discusses the real-time scalability in fintech, particularly handles the peak loads during high traffic, events like stock market opening, payment processing spikes which happen during your holiday season. So to manage these surges effectively, AI-driven predictive scaling can be used to analyze a usage pattern and then adjust the resources proactively before the demand peaks. There are like two primary scaling approaches which exist in this particular infrastructure level. One is a horizontal scaling, which involves adding more servers to distribute the load. This ensures like the systems can handle increased traffic without any performance degradation. So then we have something called a vertical scaling, which ensures that the processing power of an existing servers is increased. This increase this increases the CPU and the memory resources. Both these approaches are essential for maintaining the high availability and performance. So additionally, we can also deploy a serverless computing strategy, which can offer a cost-effective solution by dynamically allocating the resources based on the demand. So this also eliminates the need for provisioning infrastructure. And this approaches also optimizes the efficiency and minimizes operational costs. So there is another approach is like implementing the caching mechanism, such as using a Redis or content delivery networks, which can primarily improve the response times while reducing the backend load. So these strategies help with seamless user experiences during the peak traffic hours. Okay, moving on. This slide focuses on the disaster recovery and the failover mechanisms. These are the crucials for ensuring that the fintech systems remain resilient against any unexpected failures. So no system is completely immune to failure. So making a robust disaster recovery plan is essential to minimize the downtime and the data loss. So one key strategy is cross-region replication, where backup are stored in multiple geographical locations to safeguard any against any regional outages and the data corruption. So additionally, a multi-master database architecture can be deployed, which can enhance the system reliability by allowing the seamless failover. So in database node failures, if any of the database node failures happen, another takes over instantly and ensuring that uninterrupted transaction happen for the customers. So to further enhance the resiliency, chaos engineering can be implemented as a proactive strategy. So this involves deliberately simulating the failures in a controlled environment to identify any vulnerabilities before the real incident occurs. So another critical measure we can deploy is or use is to have the automated rollback pipelines. So this enables the quick reversion to the system state in case of failure, reducing the overall downtime and maintaining the business continuity. Now let's go through the security and the compliance. Security and compliance are fundamental pillars of fintech. So where a breach can be more damaging than the actual system downtime itself. So while maintaining the availability is critical, ensuring the robust security measures is equally essential to protect the financial transactions and the customer data. A zero trust security model is one of the key approaches in modern fintech infrastructure. So, operating under the principle that no entity, internal or external, should be automatically trusted. So, this minimizes the overall attacks and enforces continuous authentication and verification. So, additionally, encryption plays a crucial role in safeguarding the overall sensitive financial data, both at rest and in transit, ensuring information remains protected against cyber threats. So, regulatory compliance with frameworks like GDPR, PCI DSS, SOC2 is mandatory, but meeting these requirements should not come at a cost of performance. Going forward, advanced security solutions must be optimized to ensure the regulatory adherence while maintaining the high speed transaction processing. To further enhance your security posture without showing any down operations, AI driven fraud detections is an effective way to deploy. By analyzing transaction patterns in real time, AI can detect and prevent fraudulent activities, which allows fintech platforms to protect users while ensuring seamless transaction speeds. By integrating these security and compliance strategies, fintech, of course, can maintain a strong security posture without compromising on security, efficiency, and, of course, the user experience. Moving on to observability. Observability is a key aspect of modern fintech infrastructure. So going beyond traditional monitoring to provide deep insights into system performance and potential failures. Unlike any conventional approaches that rely only on reactive troubleshooting, observability enables proactive issues detection and resolution. The foundation of observability is built on three key pillars, right? You can have logs, you have a metrics, and you have your traces. So logs will capture the real-time system events. Metrics quantify the performance indicators, and the traces map out the journey of the request across the distributed systems. So together, these elements offer a comprehensive view of system health, making it easier to pinpoint any kind of issues. So, leveraging AI-driven anomaly detection techniques, fintech platforms can identify performance degradations before they can impact the actual users. This also allows teams to address any of the concerns proactively. Additionally, predictive analytics can forecast the potential infrastructure issues by analyzing the historical patterns and then help to prevent the future occurrences. To further enhance the reliability, filling mechanisms can be integrated, which allows the systems to automatically resolve minor failures without any human interventions. So during these manual efforts, this reduces the manual effort and then speeds up the overall service availability. By embracing this observability, fintech companies can strengthen their incident response strategies, mitigate risk before they get escalated, and then provide uninterrupted services to the customers. Okay, containerization has revolutionized the workload management in fintech. So with the Kubernetes emerging as industry standard due to its unparalleled scalability, resilience, and automation, many industries are now focusing on containerization as a go-to strategy. So by orchestrating the containerized applications efficiently, so Kubernetes enables like fintech platforms to handle fluctuating demands while ensuring like high availability and security posture is maintained. A key advantage of deploying a Kubernetes is it has an horizontal pod auto scaling mechanism which dynamically adjusts the resources based on the demand. This also ensures like the application scales automatically during high transaction volumes, such as again market openings or any kind of a holiday season. Right, during that time you can enable this HP or the horizontal pod auto scaling feature that can basically dynamically adjust your resources. Then Kubernetes also offers a built-in fault tolerant and self-healing capabilities. So if any node fails, workloads or the pods that are scheduled on that particular node will automatically get rescheduled to a healthy nodes, which minimizes the downtime without having a manual intervention. Additionally, you can have a role-based access controls, the RBAC policies and network policies, which enhances the security by limiting the sensitive financial data and critical services information to unauthorized use. While stateful workloads such as databases and financial transactions present unique challenges in the Kubernetes, proper configurations such as stateful sets and persistent storage solutions ensures like the stability and the reliability is achieved within the environment. So optimizing these Kubernetes techniques for fintech use cases, organizations can achieve operational efficiency, security, and like seamless scalability. Okay, now let's discuss on maintenance activity and the best practices, how to use to minimize the overall impact in these particular situations. So in fintech industry, maintaining the system reliability while minimizing the impact is critical for ensuring the seamless financial transactions, regulatory compliance, and customer trust. A proactive maintenance strategy is important, which leverages automated monitoring tools and AI-driven predictive analytics to detect and resolve potential failures before they affect the operations. So teams can perform regular health checks, security audits, and load testing to further strengthen their security posture. To ensure like zero downtime deployments, fintech companies should adopt like blue-green deployments, canary releases, and feature flagging techniques, which allows seamless updates without even disrupting the services. And then high availability is also crucial. So achieving through multi-region deployments, self-healing infrastructure, and robust database replication strategies that provide like automated failover in case of failures, right? So this can be implemented to make sure like high availability is achieved. Then security and compliance must be a top priority. With continuous vulnerability scanning, automated patch management, and strict adherence to the industry regulations, we can still maintain that security posture. Coming to the data encryption tokenization, which will protect the sensitive financial information from cyber threats. Database schema versioning is one that ensures like backward compatibility and preventing the disruptions when database structures change. So equally important is effective communication and incident management. So customers and stakeholders should receive timely maintenance notifications, while incident response frameworks such as SRE principles or the playbooks help teams quickly identify the issue and then mitigate and learn from those system disruptions. So conducting the post-mortem analysis is very important after the incident, which ensures like the continuous improvements and long-term stability. By integrating these best practices, fintech can achieve a balanced approach between the continuous innovation and system reliability, fostering customer confidence while maintaining the regulatory compliance. Okay, moving on to the next slide. The overall goal of the fintech is to achieve the 99 point however nines uptime, right? So which translate to just few minutes of downtime per year. Downtime leads to a financial losses, regulatory penalties, and of course decline in the customer trust. Achieving the zero downtime requires a holistic approach that includes scalable architecture, automated failover, security compliance, continuous observability, and AI-driven automation. So companies that prioritize reliability have a competitive edge as customers and partners trust them to provide uninterrupted services. So always make sure like reliability should not be just a technical goal. It is a fundamental pillar of a fintech success. Just to summarize, I think we have explored like strategies for building an resilient fintech infrastructure, including scalability, security, observability, and automation. We have gone through a security and compliance, which must be integrated into every aspect of infrastructure design. So finally, I want to thank everyone for joining me in this particular session. So I hope you like this session. Thank you.